Hello everyone, welcome to this Conf42 Cloud Native conference talk. My name is Ara Pulido, I'm a technical evangelist at Datadog, and today I'll be introducing a project called Gatekeeper and how you can use it to embrace policy-as-code in Kubernetes. So that's my Twitter handler. In case you want to reach out after the conference, feel free to do so. Let's get started by introducing Kubernetes. Obviously, this is a cloud native conference, so many of you will know, but just in case, Kubernetes is a container orchestration platform that helps you run containerized applications in production. And it comes with a lot of nice features like it's completely API driven, auto healing, auto scaling, etc., etc. And Datadog, obviously, this is not a talk about Datadog itself, but just so you know, it's a monitoring and analytics platform that helps companies improve observability of their infrastructure and applications. But today we are going to be talking about sometimes a little bit of a dull topic, which is policy. But what is policy when we are talking about software services? So basically, policies are the rules that governs the behavior of a software service. So basically what you can and cannot do with a software service. So in the case of Kubernetes, what you can and cannot do in your cluster. So that sounds a lot, when we are talking about Kubernetes and what you can and cannot do, it sounds a lot like RBAC. So RBAC stands for Role-Based Access Control, and that's basically what RBAC is already doing. So it helps you define rules of what a user or a service account can and cannot do in Kubernetes cluster. So usually you have rules in the form of a subject, a Kubernetes API resource, and a verb. So you can do things like, for example, my user, Ara, for the type of resources, pods, she can create, get, and watch those resources in a particular namespace, we can say. So if we already have this, why we need something else like Gatekeeper? And the reason why we need something else is because auth, which is what RBAC tries to solve, is just a subset of the type of policy rules that you want to create for your environment. To put a couple of examples of things that you may want to enforce in your cluster, things like only run images coming from a particular registry, or having a set of labels that are mandatory for all your deployments and your pods. These type of things are things that you may want to define somehow, and RBAC doesn't allow you to do so. So when we have our environments, our cloud native environments, in this case, we are using Kubernetes as an orchestrator, probably we also have so many other things in our stack. We may have cloud resources, we may have API gateways, we may have service meshes, stateful applications, etc. So not only you want to create policy for your Kubernetes cluster, but also for all the rest of your cloud native resources. So is there a way that we can do that in a very common way? And that is exactly what OPA, or Open Policy Agent, tries to solve. So basically, OPA is a cloud native project, it's completely open source. And the idea of OPA is that you are going to decouple the policy decision making from policy enforcement. How does that work? So the idea is that OPA is only going to get a policy query in JSON format, so very standard, very domain agnostic. And based on some rules that you have coded in a specific domain language called Rego, and some data that you may or may have stored as well, it's going to compute basically a policy decision in JSON format. And that's the only thing that OPA is going to do. And that's how it tries to completely decouple that from any particular enforcement for a service. So now you have a decision, but how do you enforce that decision into your service? So the way you do that with OPA is by using any of the integration it has. So if you go to the OPA website, there is a full list of all the integrations. This is just a screenshot, so there are many more. And because it's JSON, it's very easy to create new integrations. So there are more and more coming all the time. And this is exactly what Gatekeeper is. Gatekeeper is one of these integrations that enforce OPA decisions for Kubernetes. So the way Gatekeeper is built is basically embeds OPA inside Gatekeeper itself as a binary. And the way it enforces that is by using something called admission controller. So when you create an API request against the Kubernetes API server, it goes through several steps. It goes through authentication, so is this authenticated or not? Then it goes through authorization, usually in the form of RBAC rules. And then it goes to a third step called admission controllers. And admission controllers are a set of binaries that are already embedded in the Kubernetes API server that basically compute the request and decide whether two things, whether that's a valid request and also whether you want to mutate that request. And there are two specific ones, particular ones that are very helpful, which are validating admission webhook and mutating admission webhook. On those two, basically you can hook any code through webhooks, any code to act as an admission controller. And this is exactly what Gatekeeper is doing. So it hooks through the validating admission webhook. For now, they are also working on doing so as well with the mutating one. Once you have the policy decision from OPA, it basically enforces it at that point. So if the request that you're doing is against one of the rules that you have encoded using Rego, then it's going to block that API request at that point. One of the great things also about Gatekeeper is that it was created having Kubernetes in mind. So it's fully Kubernetes native. And by Kubernetes native, I mean that everything it's created through new CRD objects, so custom resource definitions. And custom resource definition is a design pattern that is used all over Kubernetes to extend the Kubernetes API. So you can create new objects in the Kubernetes API and then have a controller that does the classic reconciliation loop in Kubernetes that we all love. So you're able to create your policy by creating new Kubernetes objects, and the Gatekeeper controller is going to do the actions required for that to happen. There are many CRDs. Well, I think there are 3-4 CRDs that are created, but the main two ones are these two, which are constraint template and constraint. And constraint template is where you define your policy. But the good thing about constraint template is that you can create parameters for those. So you can create reusable policy, but just creating a constraint template and then instantiate that policy into as many constraints as you want. And we are going to see how that's done in the demo. But just to put an example, so let's imagine that we want to have a rule to ask for a required set of labels in our objects. So you have a name, required labels. You have the parameters here, like the labels that you're going to require for a particular object, and then a set of rigor. And we are not going to go into much detail on the rigor syntax in this talk, because the goal of this talk is for you to see the opportunity for Gatekeeper to be used straight away, even if you don't know rigor to start with. Once we have that template, we can instantiate that template into as many rules as we want. In this case, we have all namespaces require the Gatekeeper label, but we also have another rule that says all pods in the default namespace require the do not delete label. So as you can see, just by creating once the rigor code, you can reuse that policy many, many times. So that makes Gatekeeper reuse of policies super simple. And the good thing is that usually when you want to start creating policy in your Kubernetes cluster, you may probably want to create the same set of rules that many other people are going to create as well. Things like images can only come from approved registries. That's a classic one. Deployments require a set of labels. Container images require a digest. Or the containers that you have defined have to have a CPU and memory limit set. These are very common things that you want to do in Kubernetes. Obviously, the values is the thing that are going to be different from company to another, but the generic rules are very similar. So for that reason, there is an open source project part of the OPA organization called the Gatekeeper library. So the community is creating all these reusable policies that you can use out of the box, even if you don't understand Rego. So you can start getting value out of Gatekeeper very, very easily. So there are many constraint templates and more that are coming every day. To put an example of what you would encounter in that repo, this is an example of one of the templates. It's about having only HTTPS ingresses and not HTTP. So you have that template and you have the Rigo code. You can try to understand Rigo code. You can use this to start learning Rigo, but even if you don't, it's super simple to use because it has a description, it has a name, it has parameters or not. And then on that same repo, you're going to get not only the template, you're going to get an example or several examples. And examples come in the form of an instantiation of that template, so a constraint. And also based on that constraint, an object, in this case an ingress object, that is going to fail that validation. So very easily you can see all these examples on that repo and understand first what the template is going to use and what type of objects may fail that one. So this is the GitHub repo for the Gatekeeper library. It's part of the, as I said, part of the OPA org, CNCF project, completely open source, so easy to use. And another good thing about Gatekeeper that I like a lot is that it comes with out-of-the-box observability. So it comes with a lot of metrics like constraint templates and constraints, the number of requests and the latency of those requests, the number of violations, etc. We also, at Datadog, has an out-of-the-box integration. So if you're using Datadog as well, just without having to do much, you will get this out-of-the-box dashboard to start with. So you will get all your metrics back into Datadog. And we will see that as well during the demo. Good. So let's start with the demo. So this is, by the way, I have an alias to K. It's kubectl. So every time I type K, that is what it is. This is a one single node. It's very simple. It's Minikube. It's good for the demo. And I'm running Datadog already here. So I'm already running Datadog. I'm sending this data to Datadog. And I'm not running anything else. Obviously, I have some pod in kubesystem as well. So this is my pod. We can have a look to that on Datadog as well. As I said, I'm already running it. So I have here my deployments, my replica sets, etc., etc. So let's deploy Gatekeeper. That's the first thing that we need to do. And we're going to deploy Gatekeeper just using the default Gatekeeper YAML that comes in the getting started. So I'm just doing everything here by default. And you see a lot of stuff has been created. We can see that some CRDs were created, 4 in this case. We also had a new namespace, Gatekeeper system, that has basically 2 things. The controller, in this case with 3 replicas, obviously, because this is going to be used to validate your policy. It's always to have more than 1 replica, but you can define how many. And you also have an audit pod that we are going to explain later what it's for. So once it's running, so if we now exec onto the Datadog, let's see if this works. You can see that the agent, Datadog agent, has found straight away the Gatekeeper pods. So it's going to start sending all these metrics directly without having to do anything else. So let's see if everything is running here. Cool. So everything is now running and we are going to be sending those metrics as well. Okay, now that we have all running, I'm going to use some of these templates for the Gatekeeper library. The reason why I'm doing this is because I want to show you again how easy it is to reuse these things that are already coming out of the box. So I'm going to use this. This is part, as you can see, this is part of the Gatekeeper library. I just cloned this from the GitHub repo, so nothing changed there. So I have a lot to get here from. So I'm going to be using this, the required labels, and you can see that there is some. There is a name for a new object. There is some properties, so to parameterize that, and some Rigo code that is already tested and validated for me. So the first thing I'm going to do is I'm going to create that. So apply that template so I can have the new CRD and I have that template already available for me. So let's find this library general. required labels, and then template. So I just have to apply that, and it's going to create this new constraint template object. But it's not only going to do that. So if I now do get me the CRDs, it has created a new object type, a new kind of object, which is the required labels that now I can use to instantiate as many times as I need, just by using the same Kubernetes native format. The good thing also about this being CRDs is that you can store this with the rest of the configuration that you have for your cluster using GitOps, etc. So let's do that. So as I said, every of these templates come with examples. So let's check the example that we have here. It's a constraint basically that says all namespaces require an owner key, an owner label with a set of accepted values. But instead of using this, I'm going to copy this one and change it a little bit so you can see how easy it is to reuse this thing. So going back to the terminal, I'm going to copy that one. Library, general, required labels, samples, all must have owner. I'm going to copy this and I'm going to change to Conf42, for example. So now that I have that, I can edit it, and I'm going to change this to Conf42. And instead of namespaces, I'm going to do, okay, this is for pods. I'm going to change the error that I'm going to get if I don't find this. And instead of asking for a value, I'm just going to say, okay, I just need the key. So I'm going to change the name of the key to Conf42. And I'm going to remove this. Okay, so the next thing that I have to do is to apply that. Okay, that has been created already. And basically this rule is saying to a cluster, all of our pods require the Conf42 key. But we already have some pods running. We already have the Datadog pods, the Kube system pods, the Gatekeeper pods, and all of those didn't have that label. So what happens in this case? So this is where the audit pod, remember that one of the pods that were created for Gatekeeper was the audit one. So basically that pod is going to check for violations that are happening when you create new rules. But instead of removing those pods, it's just going to get you a description so you can fix that afterwards. That makes it very easy to have those coming, to create new rules without having to alter your cluster right away. So how do we know those constraints are happening? So if I say describe the type of objects and the all must have Conf42, something is wrong here. So let me see, probably I made a mistake. Yes, so this has to be singular, which is important. If not, it doesn't work. So it's pod and not pods. So let's do that again. Let's apply the constraint. It has been configured. And now if we do this, hopefully now we will get the violations after the audit has synced a little bit. Let's just wait there. Okay, here we are. So we have now all the violations, all the pods that are violating that rule. So all the pods that were already running. So if we go now to to Datadog, as we said, we are sending all that data back to Datadog. So we can see all the latency of the webhook request, the number of requests, and also we can see the number of violations here. So we had those 14 pods that are violating. So this is also a very nice way to see if you're the owner in your cluster of enforcing policy, when you're creating new rules, straight away check how many violations you have and start reducing those by modifying the objects that you already have running in your cluster. Good. But that's for existing objects. So what happens with new ones? Let's imagine that now we have this rule in place that says all pods must have the Conf42 label. So if we see this new object, we are going to create a pod for Nginx, very simple, and we are not going to add the label that is required by my organization, but I don't know. So I'm going to just try to create that object and it's going to fail. So it's going to give me a failure coming from Gatekeeper explaining to me why my pod wasn't being able to be created. So if I now modify this and I see Conf42 and I can put any value because we are not requiring a value. So let's just put April. And now I try again. Now it allows me to create. So you can see that I already was able to create policy for my pods by reusing some of the examples that I got on the Gatekeeper library. Make things very simple. Okay, let's go back quickly to the slides and then we will do a second demo. So we've seen, in this case was simple because we said all pods must have this particular label. So you only needed the information that you had on the object you were planning to create to be able to answer the question. But let's imagine that we have this other type of rule that we want to enforce in our cluster. All hosts must be unique among all ingresses. So if you have many ingresses, you have to make sure that the host name are unique for each of them. So for that, only having the information of the object that you're planning to create is not enough. You also need the information about all the rest of the ingresses object that you have in your cluster in order to be able to answer that question. We were talking about OPA. It uses two things to answer policy inquiry. It uses the policy in Rigo, but it also have the ability to have some data about that. So how am I able to, in Gatekeeper, to add new data that is going to be used for that decision making? So it's super simple because, again, it's Kubernetes native. Basically, what I need to do is to create a config object, which is a new one, and then let Gatekeeper know all the type of objects that I want to store as data to make those decisions, in this case, ingress objects. So let's do a quick demo about that as well. So we are going to use again an example. So let's go here and we have this one, ingress host. We have a template, as in any other one. So as I said, this is an example I was talking about. All ingresses hosts must be unique. You don't have a parameter because you don't need to. Just have the Rigo code that, again, we don't require that to understand. Okay, so let's create that. This is unique ingress host. And again, we have a template here. So let's apply that template first. And then I'm going to also use this sync object. And this sync object is going to tell Gatekeeper all the stuff that it needs to store to make those decisions. So again, this is here as part of the Gatekeeper library. So even the sync objects that are required are in the example. So let's apply that one. So as soon as I apply this object, Gatekeeper is going to start storing any ingress object that I create that can be then used to make a decision. Let's go to the examples. And as usual, as I said, the examples come with a constraint. That's the first thing that we need to create. In this case, the constraint is pretty simple because it doesn't have any parameters. So it's just for any ingress that we create. And We also have examples about things that are not allowed. So in this case, you can see that we are going to try to create two ingresses object. The first one, it's going to check the host that is unique. And because it's the first ingress object that we have created, it's going to be unique. So that's good. For the second one, we are going to try to use the same name. So probably it's going to fail at some point. So let's try that. Okay, you can see that the first one was created successfully. And even though it was super quick, so I created the first one and then the second one, Gatekeeper already had that information on that. So it created the first one successfully, and when it tried to create the second one, it checked that sync objects that it already had and said, okay, there is already an ingress that has that same name, so I'm going to stop this. So again, not only you can create policy with the information about the object that you are creating, but also in relation to the objects that are already in your cluster. So that's all I had for this talk. I hope you learn about Gatekeeper. If you didn't know, that project is a fantastic project. Makes super simple to start using policy-as-code in Kubernetes. So check it out. And thank you very much. Bye.